Welcome to part 4 of our live training session here with our turbocharged BMW M3 running on our EMU Black standalone system. Last video, we calibrated the part throttle cruise area of operation. That's where we spend about 80% of the time when we're actually driving. Now we're going to turn our attention into going into the full throttle area of operation. Now we're going to be doing this in a very specific manner. We're going to actually tune the engine in its naturally aspirated state, removing the charge piping from our intake plenum, and then we're going to put it back on and do pulls in boost. We're doing this specifically because we're calibrating in the alpha N mode with the map multiplier. It's going to allow us to simplify the process, getting our fuel and spark timing sorted out in our normal main VE table that's based on throttle position, and then introducing boost pressure on top of that once that calibration process is done. We're going to have a lot to cover within this video, so let's jump in and get started. Welcome back to our live training session here with our turbocharged BMW M3. In our last video, we looked at the part throttle optimization and calibration process for both fuel and spark timing. This video, we're going to turn our attention into doing full throttle tuning. Now, we have a relatively low wastegate spring on this setup here. It's about a 4 or 5 pound wastegate spring. We're actually going to be tuning it in the naturally aspirated state first. And how I'm going to do that is I remove the charge pipe from the intake plenum. Now, the reason why I'm doing this and going through the effort and the trouble is that the table is set up on alpha N base. Now, we have individual throttle bodies and it's forced induction. So we need to remove the charge pipe so we don't have any boost going into the engine, and we're just going to essentially tune it naturally aspirated. That'll allow us to deal with the fuel and the spark and deal with the variable cam timing and get that all sorted out so that we can just put the charge pipe back on, and then we can account for then the positive manifold pressure and boost pressure as we're going to be introducing into the engine. Now, the reason why we can do it in this manner is that we have our option here. If we take a look at our software under fueling general, under our setup tab, fueling type alpha N with map multiplier, and take a look here, and map based ignition. So we'll find, because we have this map multiplication going on in the background, it's scaling and compensating for the rate of change in our manifold pressure in a linear rate. So if we tune it in our 0 to 100% scale in our throttle angle here, because again, our table here is 0 to 100%. We can see as I'm moving my foot here, it's going from 0 to 100%, it's moving in my table. This will account for the naturally aspirated condition of the engine. Then when we introduce boost, it'll have a background multiplier. It'll automatically scale it for the increase in boost pressure. We should find that everything's going to work right. This is going to be a procedure you'd have to use for one of these BMW dual Vanos engines that have the individual throttle bodies factory, or RB26. That's going to be probably the more common application you'll find with an ECU Masters EMU Black style application. So the RB26 has individual throttle bodies and it's turbocharged. In order to properly map that out in this speed density format, you want to be using this TPS alpha N style mode with the map multiplier and map based ignition. That's going to be how we have to deal with it, because we don't have a mass airflow sensor anymore to account for airflow based tuning. So this is what we have to work with. So in either situation, this is the procedure. If you have just standard speed density tuning where you have map as your input to the table here, you don't have to remove the charge pipe. You can actually just go forward and begin your calibration process and kind of skip this step. There's a little bit more steps in this video that we're going to go over. So I'm going to be tuning it naturally aspirated. Then we'll put our charge pipe on, and then we'll go and make some pulls and boosts, make sure everything's good. In addition to all of this, we have our dual Vanos or dual variable cam that we have to deal with. We're going to be mapping it out and tuning it in the naturally aspirated state. Then when we put the charge pipe on, everything should work because it should be all situated, whether it's NA or boost. We're also going to have our spark timing to deal with and that we need to optimize. And we're going to use this opportunity when we have no charge pipe connected. We're going to use this opportunity to figure out essentially 90 to 110 kPa range. This is our full throttle load range in our map sensor reading. We're going to figure out our spark timing, but more importantly, we're going to figure out our knock control threshold here. So we have our engine noise table. We can, with low spark timing, we can populate this table out so we can have the proper floor or the noise floor. So if we're below that particular voltage at a particular RPM or throttle angle, or in this case actually boost pressure, it's going to ignore it and not think it's knocking. If it oversteps that, then it'll think it's knocking. This will give us a great way to establish our floor with low spark timing in the naturally aspirated state. Then we can optimize our spark timing, watching all things associated with our knock control here, and then carry that forward into tuning and boost. So Again, you can replicate this without tuning, without pulling the charge pipe off. You don't need to do that if your engine is not in this alpha N mode. Again, it's just an extra step, kind of an extra layer here. So we're going to be dealing with our knock control, and we are going to be dealing with our variable cam control here. So we're going to be learning how to map this out. It's actually relatively simple. These tables are based RPM versus throttle angle. So thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.